Thank you everyone for joining our SE Hangout, Encourage Data Scientists to Smile, MLB Ops with Nomad. Hope everyone is staying safe and healthy out there. Today we have HashiCorp Senior Solutions Engineer Josh Jordan presenting. Josh is going to discuss Nomad's orchestration capabilities and explore where Nomad fits in a hybrid ML Ops pipeline. I'd like to note that the webinar is being recorded and the recording will be made available after post-processing. I'll email it out to everyone, usually within a day or two. Please submit your questions throughout the presentation through the Zoom Q&A portal, and then we'll answer them at the end. So with that, let's go ahead and get started. Take it away, Josh.
Cool, thanks, Allison. Yeah, get my slideware queued up here. All right. Hopefully everybody can see that. So it's interesting. What we're going to talk about today is really machine learning operations, not necessarily machine learning. If anybody joined and wants to have those kind of questions, I'm happy to talk about that kind of stuff, but this is more or less surrounding the operations of machine learning deployment, like deploying models, right? So we'll kind of go into that. And really, the point of this is really to discover where Nomad fits, right? We know Nomad is an orchestrator, and I'll get into that for those that are unfamiliar with what Nomad is, but the idea is really to kind of dive into how Nomad fits in this kind of orchestration lifecycle for machine learning models. Is it a good fit? Is it a bad fit? Whatever. And I think as you'll see, like there's definitely a place for it, but ultimately it's going to depend on how the industry kind of develops its best practice moving forward to see where it finally lands in the space. But that's kind of the point of what we want to uncover. And so we'll kind of begin with like, what is ML ops, right? Google estimates that there's a lot of data it's stored. Companies have it, sure, they've been keeping it, collecting it for a long time. Some of it's structured, some of it's unstructured. But really, Google estimates about only 1% of it's actually used, right? And when I say used, I mean used for operational purposes. Sure, you might throw some stuff in ML models, you might do some type of web marketing campaigns, components like that, but like actively used, considering how much data is out there, it's not really a ton of it that's being used. And so there's a huge opportunity for moving into machine learning, moving into other data types of operations, AI and deep learning in particular. And so what we're starting to see is like the trends that have been happening, especially at the deep learning revolution of 2012. Like since then, especially, we're kind of moving into that early majority phase where some companies are using machine learning, they might have some manual MLOps processes, but we're really kind of moving into this phase where more and more companies are going to start to adopt it. And the problem is that there aren't really any best practices. The idea of MLOps is actually fairly new. And it does borrow from the idea that DevOps will be applied, the automation, CI/CD pipelining, the infrastructural provisioning, all those components that support the operation of developing and deploying a model. Yeah, we're going to apply that to machine learning, but like what are the best practices? And really outside of what Google tells you to do, there aren't really a ton. And so the automation part is also something that, although we talk about it and you will read a lot about that in the literature, also doesn't really happen in practice either. It's something people will strive for, but much like moving to the cloud, it's more like an end goal that just takes time. It's like a journey. And so really you could see why, because it has a lot more to do than just the ML code. Right? You've got the ML code, sure, which you think of it like an application for those that are familiar with application development. Like you have an application, the logic associated therein, and you want to get that out to a user or a business user or something like that. And the idea is that just in and of itself, that's not helpful. I mean, sure, I can run it on my local machine and everybody can clap and rejoice, over my shoulder, but that's not really the same as getting it to broadcast media and broadcast user bases. And the same thing applies for ML code, because oftentimes the ML code and the models themselves are applied to data in real time. And that data is typically gathered by applications, right? So you have in-facing services that are capturing data all the time, and you feed it to your models for analysis internally, right? And so to do that really requires a host of services, and really these are, just domains I would consider. These are just domains of like execution that you have to kind of work in that are not models, and we have to kind of account for that. And this is kind of where the idea of ML ops emerges, is because really, deploying real-life ML models is a lot more than the code itself, and it's really hard to get there to an end-to-end type of pipeline. And so, oftentimes people would spend a lot of money on like these manual processes to get ML models into production, or even to get them into like some type of environmental staging process. And because of all that, I guess you can call it an economic factor. There's an economic driver that now puts us at this point where, look, we need to have some end-to-end ML automation process. And so we need to kind of develop tools. We need to figure out what to do. But the best practices are really just kind of emerging. And so what you start to see in this trend of ML ops in general is you'll see a lot of conversations around a data scientist. And although data science, is a broader understanding of AI, ML, the subsets therein, deep learning, neural networks, all that kind of stuff. Yes, data science can encompass all of that. It certainly can as like the practitioner of the field. But usually what people are looking for in a data scientist is a superhuman, right? They are actually searching for somebody that can do everything because that's what they've been told. They read the same article that we all read that said they were the sexiest, profession in the 21st century. And so therefore, you get a title like that, everybody expects you to be able to do everything. And so that's what ends up happening. You'll get people that may or may not be able to do everything. They may be able to build the model code. They may be able to use TensorFlow. They may have DevOps experience. They may be able to use infrastructural tooling. They may be able to do everything, but it's probably not the case. And then they also actually get isolated. So they're typically brought in, and even if they're not asked to do everything, their team is isolated because their team kind of functions outside of the normal business unit. A lot of these organizations are immature in their data practice because they don't really know what to do. It's like, we know we need to do it, but we don't really know, outside of trying to find this team over time and this group of superhuman people, like, what do we do with them? Like, do they interact with like our normal application? Like, where do they fit in our business unit? And so that becomes a problem that typically isolates these people as well. And then inevitably you will get asked, hey, I need this spreadsheet for this report so that I can go present it to my boss in this meeting. Can you do this for me real quick? Right? Not necessarily data science, sure. Business analytics are part of it after you run a model and stuff like that. I'm not saying it's not a component, but it's certainly not what you signed up for when you took this job. And so inevitably what happens is they leave. Now, it's not like an astronomical percentage, but it is number 2 on the list of developers. There was a Stack Overflow survey that was done. And of the respondents, number 2 on the list of people looking for a new job is data scientists, right? So this is of all developer types. So machine learning engineers are number 1. Obviously, data scientists could be like a JavaScript developer or whatever. This is like any type of developer, what would be considered a developing profession. Data scientists are looking for other jobs. And it all has to do with the operations surrounding supporting them, right? It's not that they don't love the job. It's not that they don't like working with smart people and doing the work of data science. They just don't really have the support to actually be successful at it. And so what we want to do today is we kind of want to apply or understand, at least to some extent. I'm not going to build an end-to-end pipeline. That would be something that would take a lot more time. But the idea of what we do want to cover today is, how do we apply DevOps to ML practice in a way that can help data scientists kind of bridge the gap and get to where they're going? And if we think about, I like this diagram actually, because if you think about it, really the way this is going to work is you've got an ML model that you're going to put on a pipeline, and that pipeline sits in between 2 streams. One is the data stream, right? So that data stream might be an external URL. That data stream might be some process that yields a CSV file. It could be a database. It doesn't matter. There's some external source of data that should be clearly isolated from the pipeline. And then there's the code that actually supports the pipeline. So if we think, obviously from a Terraform perspective, although that's not necessarily a requirement for any of this, but infrastructure is code to build the infrastructure for the pipeline. And then obviously the orchestration tooling so that we can manage services, especially if you have situations where you're leveraging cloud functions, you might be leveraging other services in your environment and also reaching back to on-premise. The service ecosystem of organizations is becoming ever more hybrid. I think oftentimes we think about hybrid as oh, I'm in AWS and I'm in Azure and I'm in private cloud. And that is true. I actually think hybrid has a lot more to do with just all the services that you use. You might be in VMs for some, you might be in containers for others, you might be, doing, remote procedure calls for others, like gRPC in other cases. I think it's just the variation of services are what really make more of a melting pot hybrid type of ecosystem. And that's really what we're talking about when we're talking about hybrid type of processes. But anyway, what we're going to do is we're going to kind of leverage this pipeline to take our code and our data, marry the 2 together, and just run it on a regular cycle, right? That's really the goal of MLOps. Now, there's a lot of components in between here, but the goal of MLOps is to accomplish this, to make this a seamless CI/CD process. And of course, as always, you have to pick the right tool or it's unnecessary to even go do anything in the first place, right? And so this is where I think Nomad had a unique potential to help us out, right? We have 4 products here and they're all great. And I think I oftentimes find myself, using Nomad as like a Kubernetes alternative because it's easier to use, right? And you can use it that way and it's great for that, sure. But another thing to consider is just a federated workload scheduler, right? That's all it does. It just federates any type of workload you can imagine. And in this particular case, where we know we're probably going to be dealing with legacy environments, we're going to be dealing with, again, those hybrid services and ecosystems, it's a fantastic, at least first choice to go look at is like, can I even do this? I know there's other tools I could use. There's Airflow and other things, sure, but can I do this? And if we think about the Nomad architecture, what we're going to have here is we're going to have 3 servers, and the servers are going to manage like a fleet of clients. In my example, it's just going to be 3, but it could really be any number of clients. And you have to think for certain machine learning workloads or any type of data-driven workload, that fleet could grow. Also, the size of the VMs could grow as well. But just to get a general understanding of how this is going to work, these servers are going to orchestrate jobs across that fleet. So you can think about it as like, I own the fleet, right? I don't care where the job runs. I'm just basically training a model and deploying it, right? So I don't care which VM it runs. I just want to make sure it runs. And that's why, again, I don't have to worry about ingress points. I don't have to worry about pushing it to a certain area unless that's something I specifically want to do. Just in general, the workflow is, run the job and it runs the model and does exactly what I expect it to do. And I never had to consider where it ran, right? That's hugely valuable when we're thinking about data operations, where a lot of times your space is going to be constrained on the VM and you definitely want to make sure that you're running it where it can run, right? There's space to run the job, but you also want to make sure that it executes and finishes and it's not like some weird networking error as to why it's not working. And so I think by the end of this, what we'll see is that Nomad kind of has this interesting place where the pipeline itself, it can run, sure, but there's other areas in this is more of like a production grade ML pipeline type of automation structure that we're looking at. There's other places where it can play as well, because don't forget, it can also host other services. So your end user services, they're going to interpret the model, maybe gather data to feed the models. It can play in that space as well as running type of green-blue experiments. So like if you want to run a pipeline, train the data set, and then run it again and like different, like changing variations on the fly, you can do that with Nomad. The main thing though is this federation, right? If we think about federated learning, which is becoming a popular thing, the idea of federated learning is I want to run the same model, train it across various architectures and various infrastructures, and then aggregate all those model results into one great unified model. Well, as a federated workload scheduler, I can't think of a better choice than Nomad for that, right? And really our example today is going to be kind of the beginning of what that would look like. So I'm hoping that, that it kind of uncovers, oh, Nomad could be used for that thing in particular, as well as some of the other components we pointed out here. The goal of any type of demo or thing that we do is to not like boil the ocean, so to speak. And like I told you, I'm not going to do an end-to-end pipeline. The idea here is we're going to really experiment with this idea of Nomad as a kind of scheduler of modeling and see if we can get it right and then iterate on it moving forward, right? The idea is that I would take what I've done today and then move it to the next phase, the next phase, the next phase. It's never a one and done thing, and nor should we ever expect that. So just a quick precursor of what's happening. I'm pulling data from Salesforce. That's my external source. I'm actually using a Google Cloud function for that. The ironic part of all this is I could have used Dataflow, right? I could have used, I could have just uploaded a TensorFlow model straight to GCP, but the value of doing this in Nomad is that I can actually take what I've done and translate it directly to Azure or AWS or on-premise, it doesn't matter, right? And so the idea is, that's one thing I want to definitely point out is why I did it this way instead of just doing the GCP way. And we'll talk about that towards the end about why that's extremely valuable. But anyway, my data source is Salesforce. I'm actually going to run my model in a with TensorFlow.js. For anybody that's a JavaScript developer or knows Node or anything, TensorFlow.js is a fantastic addition to your pipeline of things you should know. I'm going to run the model code in a Docker container. I'm going to train it. I'm actually going to test it, do like an integration test on part of the data, and then I'm actually going to push the model versioned. A version model is very important because you want to be able to reference the model later so that you can know what worked and what didn't, right? so that you can iterate on the model and handle degradation of data quality and accuracy over time. We're going to version the model and we're going to store it in a GCP bucket. Again, you're probably like, why didn't you just do all this in GCP? It's like, I could have, but the broader point is that I can do this in Azure as well as AWS, as well as anywhere else Nomad will run. And since it's a binary, it'll run anywhere. And then this final piece over here is we're going to, build, learn, and adjust. It's like, cool, we got this working. Now let's iterate on it. Let's make it better. Let's see what we can do to transform it and make it more effective. That was an unnecessary slide, so we'll just go ahead and do the demo. Before I jump into it, does anybody have any initial questions? I want to make sure that we at least have some of these burning questions that we have before we dive into the tool. Okay, great. So you can see I already have Nomad running. This is the Nomad UI for people that are unfamiliar with it. I actually deployed all this stuff with Terraform. I wrote a blog about this too. I'm sure they'll publish it sometime. They'll probably publish it tomorrow or sometime next week if you want to read more particulars about how I did everything. You don't have to. You can point and click all this stuff into existence, but obviously I'm biased to use Terraform, so I did. But the idea is that this is running 3 server nodes and 3 client nodes. And Docker is pre-installed on them, right? Docker's pre-installed because I'm gonna run Docker, and then obviously, any other thing that I would want to run, like let's say if I wanted to run like a binary from Go or something, I would need for that to exist on the VMs before I could actually have Nomad run it. But in this case, the beauty of having Docker is that I can run pretty much anything in that Docker ecosystem as long as Docker is on the boxes. So just know that as a prerequisite, I did that. As you can see, there's not really much to the UI other than we're just looking at it. And we can see that there's some components that I can look at. I got my clients, I got my servers, cool. I got, IP addresses where they're all at. And then I've got a job, and you can see that I've run this job in the past. And we'll go over, don't worry about parameterized like that. I'll cover what that means when we dive into the code, but I just want to kind of give you an idea of it's running, and this is where we want to interface with it. We could also interface with it via the CLI as well. But first, let's look at the code. Kind of the marquee part of a Nomad job is its simplicity, right? I look at this, and this again, why I use it instead of Kubernetes for like my normal service-based deployments. I look at this, and sure, it might be because I write a lot of Terraform and HCL isn't foreign to me, but I just feel like this is just easier to understand. I write a lot of JavaScript, I write a lot of Go, and so to me, it just feels more like code than YAML does. It also feels less complicated, right? It's almost like I can reason about it as I go, right? I have this job, it's called sales close prediction. I'm gonna deploy it into a data center. I'm gonna declare the type of job. In this case, it's a batch. For those unfamiliar, Nomad will run a batch service and a system job. In this case, we wanna run a batch job because we're just training the model and then dumping it off into an external storage system, so I have no reason to keep it up. There's no reason to keep it operational, so there's no reason for it to be a service. There's also no reason for it to be a system unless I wanted to run it on every single machine that was under management. Again, I don't really care where it runs, I just want it to run. You can see here, this is a parameterized job, which actually means we're gonna run it like a function. And that's a really cool feature of Nomad is that, yeah, I can queue up a job, but I don't have to execute it right away. I can just basically treat it like a partial. For those that know what a partial is or have used libraries for doing more functional-based programming. Partial just basically sits in a queue and waits for you to pass it arguments that you then call it or apply it. And that's what we're going to do. And these are the arguments that it requires. So these can be considered arguments to the function. I'm going to pass it a save path, a data path, a prediction path, a data URL, GCP creds, a bucket path, and model version. The reason I'm doing this is because I'm going to use these variables later or at runtime, right? So this is super cool because now I can queue up Nomad to run like a function and then call it like a function, and it'll actually apply all the components at runtime, which then allows me tons of flexibility in how I actually marry or interpolate these variables together. And as long as my application that's running knows how to interpret them as well, then I can use them, right? And we'll go over the individual parts as we approach them, but just wanted to kind of throw that out. I am running this job like it's a function. So you can see we've grouped the job. It's pretty reasonable. I'm going to train and save a model. Cool. How many are you going to run? And this is important because this could be 1. It could also be 1,000, It doesn't really matter because I'm basically running an instance of this grouping on a VM, right? The only thing that grouping guarantees me in Nomad is it says, hey, any task that you put inside of group, we're going to make sure that I run on the VM that it's deployed onto. Why is that valuable? Well, because these tasks are very dependent on each other, right? I'm treating them like a sequence, almost like, like a sequence of tasks. I'm going to train the model, and then I'm going to drop the model file somewhere, and then I'm going to wait on that file to be available, and then I'm going to copy the file and put it in GCP. Those are very dependent activities that I wouldn't want to cross-pollinate across environments. But anyway, you can see after I've declared the count, I have a volume. This is another fairly new feature of Nomad, which is really, really valuable in this case. The volume is essentially a mount that I put on the client nodes. So every single client node has this directory called models. I know that because it's called type host, right? There's other types that you can use, but I just use host in this case. And that directory is going to share data across my tasks. Anybody that's familiar with Nomad knows that there's an allocation directory and there's also a local directory where you can do the same thing. The reason that I'm doing it this way is because it makes interacting with Docker infinitely easier, especially when I also have an exec job that I'm using. Not every one of these things is in Docker, and I did that on purpose. The idea was that having Docker for some of my jobs and then also being able to run exec is something that makes this extremely more flexible than what we think of when we think of container orchestration. I can actually do, this is again an example of the kind of hybrid deployment that I can run literally inside the job file itself. And the reason I do this is I can share the volume mounts across all my services without having to declare any mount. Like normally if you want to do that type of thing with an allocation local, you have to declare the mount, you have to drop it into the, you have to do the interop between Docker so that Docker knows where it's at. And to me, just volume mounts is much easier. I can just basically declare the volume mount inside of the task itself, and it'll just drop it. It will be available at the temp directory inside of this container when it runs. That's much easier when you think about application code that has to interop or expects this destination to exist. It's much easier to do that than it is to have to finagle with the infrastructure of making my Docker volume mount correctly. So that's a cool feature that I'm using here. Just know that there's two types. There's the volume, which is the top level group. At the group level on the Nomad client, I'm going to declare a directory where I'm going to store things. And then inside of each task, I'm going to have a volume mount that references the source. The source, again, was that directory models. You just tell the volume mount, hey, grab models. This is the destination I want you to save it as when you run this Docker container. So I want you to store it under user src app models. Right. You can see here I have some resources defined for this job. We'll get into that a little bit later, especially as to why this is the way it is. And then the driver, again, you have different drivers that you can run. I kind of went over these already. I'm choosing to run the Docker driver for some tasks, and I'm running the exec driver for other tasks. The only other thing that I want to cover about the kind of the structure of the code here, outside of, we get into interpolation a little bit more, is the lifecycle hook. This is what allows me to treat Nomad like a sequence of operations. Normally, Nomad doesn't do this, right? Under normal circumstances, Nomad runs everything in parallel, runs it all at once. It's like even if you group tasks together, you just want to run them all together, right? But what we want to do is actually treat it almost like a MapReduce, right? I want to do a thing, wait for a thing, do more things to the thing I waited on, right? In this case, I'm going to train my model first. Hence, it's called train. Inside of this Docker container is a bunch of basically TensorFlow code that sets up my model, trains my model, does some initial data massaging before passing it to the deep learning network. Like, it's just doing a lot of things that don't really matter because this could be any model that you wanted to run. Like, it's totally arbitrary and why I don't want to spend a ton of time on it. It's more about the operations of, less about how to run it. But the idea is, I have this model. It is going to run, and then its ultimate job is to leverage this output path, the save path, and it's going to drop the file into the save path. And all you need to know is that this save path actually uses the version configuration here and translates it into a directory, a subdirectory inside of models. So by the end of this, when it runs, it's going to basically say, hey, look, you got this model version that you passed me. You got this allocation ID, which is unique to the count that you run for the group. So each one, there'll be two totally different allocation IDs. you obviously want to create this subdirectory called version underscore allocation ID, and you want to save it underneath models. And that's what we're going to see. And then the other things are obviously the data path has to do with where the prediction, has something to do with the predictions. The predictions, they're stored on the box. I don't do anything with them. And then the data URL is just, where is Salesforce at? Right? So like where is your Salesforce data coming from is what it expects. So this was me having to build the application stuff. You may not require this if you run this on your own, just to kind of give you an idea of what's going on under the hood. The second task is an await model task. Now you'll notice it also has a lifecycle hook attached. And if you paid attention to the first one, they're exactly the same. They are both pre-start hooks with a false sidecar. What does that mean? Well, pre-start hook means you obviously want to run before the main task, or the main thread is a way to think of it, right? Sidecar means you don't want it to be long-lived. The second it's done, it's dead. You no longer do anything with it after it's completed, which makes sense based on what we want to do. Now, you might be thinking, well, you're doing both of these like that, so won't that mean that they will run in parallel? And the answer is yes. Both of these tasks are going to run at the exact same time. What makes this one helpful is that I am actually just having it sit and wait for my model to be available. It just sits there. Again, using variable interpolation to do all this stuff. It's just sitting there, waiting. And once it's available, then it exits. It just dumps to dev null and just exits. That's it. That's all I have it doing. I'm just sitting there waiting. And you'll see this pattern with lifecycle hooks, because right now all we support is pre-start. There is support for at least 2 others where there might be more flexibility in how we do this. But for what I had to do, this is how I ran like the sequence of steps by just leveraging essentially a busybox to just wait on a file to exist. Once that file exists, the main thread runs, and I know the main thread, the main task, store model GCP, has a leader of true. This is what identifies it as main. This is important because these guys, if they failed and they were the leader, then this would never run. Store model GCP would never run. So by marking it as the leader, then it allows the other 2 to run, finish, complete, and unless this one dies, unless this task dies, then everything else will run to completion. Going back to it's using exec, which means it's just going to run a command on the box. Because it's a GCP VM, it already has the gsutil SDK built into it. So I don't have to run it in a Docker container or anything. I can just call this directly. This is convenient for me because one of the reasons I chose GCP to do this because it's convenient to just go ahead and run this. But you have to think, if I were going to port this to Azure or AWS, I would actually probably want to use a Docker container and just pass in, because I'm already passing in the credentials anyway, and pass in the credentials to that Docker container so that I could still run this command. You can do it either way, but if you're going to do more of a hybrid type of ecosystem, that's probably what you want to do. Okay, so that's the code. That's what it does. If we have any more questions about that, we can deal with those at a different time. What I'll do now is I'm just going to run it. Right. So the ML pipeline, we know our jobs are here. The way we do this, go to jobs, Nomad, plan, sales prediction, Nomad. Cool, it's going to say I need to create this. You don't have to pass an index. It just, it's an easy copy and paste step. The reason that I'm doing this is, it just gives you that extra blanket of security to try stuff. Now keep in mind, I'm not going to execute this immediately. Because of the parameterized stanza, the definition, it is not. It's just going to treat it like a function. It's like, all right, you got a partial. I'm waiting on some metadata before I ever fire this guy off. It's going to say the job registration was successful. We can actually take a look at it. You can see that this is kind of like the previous one that we ran. We just kind of looked at it's running. It's just kind of sitting. All right. Now, I have abstracted a script just for ease that'll actually let me deploy the model. You can see in here I have all these components, like where all the things are that I'm going to use and need. I'm just letting you know that, how you do it is up to you, but I have abstracted it into a script that, again, is in the blog when that comes out, if you need to look at it, for deploying this. Now, it expects an argument. The argument is the version that I'm going to use. Now, you remember the count was 2, so I'm going to pass a version of 004, just for arbitrary reasons. And it's going to start running the job. You'll see that it evaluated everything. You'll start seeing that it's running. I want to start looking into this. You can see there was the dead one, which doesn't mean it failed. It just means it's dead. And then you can see that it's running these models. 2 versions, 2 allocation IDs, because I did a count of 2, right? If I dig into these, you can start to see when these are green, they're running, right? So the idea is that this is all setting up. Now, you might be thinking, why are you running the same version 2 times? And the reason why is this kind of goes back to that federated learning type of thing. With federated learning, if you're going to run a machine learning model on, I don't know, let's say 50 different machines of different types to get like a better aggregate model, you probably want to keep track of what version you ran, right? And so the idea is that you wouldn't want to run different versions of the model because that might complicate the data. So the idea is I want to make sure the version's the same. The allocation ID is what makes it unique, right? And so I think that's really where we get value in that, is that it'll take that version ID and it'll tack that on, but then I can keep track of it later, right? And so you can see, I think you saw some of this, the compute. Let's actually go to this other guy that's running. Yeah, you can see he's running some stuff. And they'll start running, and we can actually look at the, let's see, I should use bigger boxes. Let's see how terrible it performed. You can see it just pulled out the steps. So not a very accurate model, right? But the idea is that it ran that. Should have ran both. One of them's complete, one of them's still running, so we're still waiting on GCP, on the other GCP task to run, or it's just sitting waiting on the files. Let's go to functions. Let's go to here. You can see our prediction. One of our components is there with that 004 on it. We're just kind of waiting on the other one to show up. It's still sitting on it for some reason. But anyway, one of them's there. We'll, when it finally, just to not interrupt conversation, when it finally gets there, it'll show up. The idea is that here's our training prediction model. We have a model that we can reference later. All this orchestrated through Nomad, and then the other one will show up in a second with the 004 and a different allocation ID. And again, going back to why I do that is because I want to keep track of my versions, but I want to make sure that I have some type of component that allows them to be unique, and that's what the allocation ID is for. Now, with that said, I can iterate on this moving forward, right? I could change my model out, I could pull a different Docker container, I could do all sorts of components, I could federate across Azure, GCP, AWS, and VMware, it doesn't really matter. The point is that I have like now at least the beginning of a pipeline that works from start to finish and allows me to keep track of model versions, and with a few tweaks here and there, especially in this area with this particular job, I can then push it out towards other types of components. And so really, I don't know if I had any other slides left. Wait on that to run. We're going to this. So MLOps is emerging. ML is hard, right? It's easier with things like TensorFlow. For anybody that's used TensorFlow, I mean, TensorFlow is getting real close to just putting everything in a single box, which is really nice. And especially on platforms like GCP, where you can just upload TensorFlow directly, like any custom models, right? Or you could use AutoML, stuff like that. There's play for this in the public cloud space. But if you're not on that, or you're not moving in that direction, or you have more of a traditional journey from legacy to hybrid ecosystems as far as like your cloud footprint looks like, that doesn't help you that much. And so the idea is that ML is hard just in and of itself, but building the operations around those very complex environments is where I think Nomad actually has a place. I don't know where it lands exactly. Obviously, having to finagle a lifecycle hook without the support of the other 2 lifecycle hooks to actually wait on a file to show up can be error prone, right? But the idea is that I can do it. I can accomplish the goal. Nomad can be that orchestration piece for my pipeline, and the fact that it'll run anywhere and it'll run any type of underlying job makes it really, really valuable, especially if the industry starts to move more towards federated learning. If that's the case, I can't imagine you'd look to anything else, right? Unless you're just going to run it from the code yourself, which you can do. But the idea is that most of those operational practices are better when they're protected. And let's just talk about Nomad Enterprise for a second. Yeah, I could have like a fleet of TensorFlow ninjas that are basically doing their entire DevOps model development, training, everything from their local machines or from wherever they work. Yeah, I could do that, but how are you protecting that? How are you guaranteeing they're not holding the biggest GPU boxes on the planet and spending like gazillions of dollars a month? How do you do that, right? Nomad actually you can, right? You can actually control where jobs go. You can control, you use Sentinel to kind of manage and namespaces to kind of manage who has access to what, who has access to run what jobs, what types of boxes they can run them on, right? So that process part is really where Nomad at scale starts to separate itself from anything else. We just need the more features to develop, but they're on the roadmap. So I think there's opportunity for Nomad to really have a nice place in the MLOps space. Just ultimately where it lands, we'll see. Ultimately, the goal is to really just get support for data scientists, right? They're not superhuman. They're not. I mean, they're great, but they're superhumans with constraints, right? The idea is that to expect Superman to come out of the sky and save you is highly, it's just untenable, really. And so the idea is that to have a team built around a data science practice is a much better kind of goal, and to have MLOps as the centerpiece of gluing everything together is ideal. And then maybe they'll smile like this cat. Okay, that's it.
That is great presentation. I can't get the cat out of my head now. We do have some questions, so I'll read through them. And if anyone else has additional questions, please feel free to put them in the Q&A box. Well, the first one that was answered here is the lifecycle hook for a single group, i.e. if a pre-start hook, is it a task that is run before other tasks in the group?
Great question. It's run before the main thread. So actually, I'm going to share my screen again just so we can get back to it, because that's a good question, and it's very, very important to understand. So if we take a look at this file here, right, the lifecycle hook, you can see this one's pre-start. That's one of the tasks in the group, right? There are two tasks that have the exact same lifecycle hook. Now, what that means is that both of these tasks are going to run at the same time, but before the main thread. The main thread is identified with the leader equals true. So there is no, hey, make this one run before this one, but that is going to be future work, because the only lifecycle hook we support right now is pre-start. So with the other lifecycle hooks, you would be able to do that moving forward. But right now, yeah, I guess I kind of had to finagle like a watcher to wait for a file to exist. But if you think about MapReduce, like that's really not outside of what most MapReduce functions are anyway. You wait for some file, some data, and then you transform it and carry it on the pipe, right? So it's not unreasonable to do this type of thing if that's the goal you're trying to accomplish. But if the answer is, can I, set precedence on one of these? The answer is not right now, but I think in the future you'll be able to.
Okay. How were the parameters sent down into the Nomad run?
So I did that when I ran my script. So first we'll cover it in the file here. So you can see this meta required. These are essentially arguments. So when you think about a function, these would be parameters that you pass a function. When I have this parameterized stanza and then I say the meta that is required or meta that is optional, basically you're saying I am able to pass these functions to Nomad. Now, when I run the job, it probably would help if you looked at it like in a code editor and not like ugly orange text. But if I just pass it with a meta flag, right? Another way to do it is you can pass it with a file, and I actually make note of that here, and you can look on our documentation and see how to do that. But you can actually pass it as like a JSON file and then parse the JSON in the environment. So this is probably actually a little meta tag heavy, to be quite honest with you. I guess one of my first optimizations would be to use a file instead. But you can choose, you can either pass a file or you can use meta flags.
Okay, great. Does HashiCorp have published examples of Sentinel policies for Nomad?
I don't know. I know that I don't know if anybody else on HashiCorp's on the call can answer that. My guess is probably, because I know that's a big initiative for us right now. So I would assume yes, but I'm not 100% sure, to be quite honest with you.
And I think you touched on it a little bit, but is everything you showed today available in open source, or are any of the features enterprise only?
So the Terraform used to deploy everything is. The Nomad job should be, but it may not be. I will look and make sure, and if it's not, I'll have Allison append it to it. The model is, think, I think I have the model as private right now, so I can make that public. But again, keep in mind, the model is not really that important, right? You could use any model. Like you could use a TensorFlow library if you wanted to. It's just, I just wanted to do something very in particular. But yeah, I will make sure. If it's not, I'll make sure.
Okay, great. And is it possible to integrate with Datadog to track activity and changes with Nomad?
Yeah, so you can integrate, there's a lot of integration points, right? So you can integrate with, I mean, you could actually integrate with the, if I really wanted to, I could integrate with GCP and just like dump everything in the Stackdriver if I wanted to. But yeah, like the idea is there are integration points. I recommend you take a look at our website to see exactly what they are. Much like all the tools, it's plugin based. So there's a lot of integration components. And if something doesn't exist that you want, write it yourself.
Okay, and lastly, if you do have a preference for which clients the Nomad jobs run, how would you specify that within the job?
Right. So you can use the kind of the affinity parts. You can use, I mean, there's the, you basically characterize where the job runs. So there's a stanza that you use to actually isolate, I want it to run here. There's also another one like preemption. Like if you wanted to have, let's say you had like, let's say this model was the most important model in my organization. Like it had to run every day because we couldn't run our organization without it. I could use preemption in the same way that I could use, kind of like the resource configuration where I'm going to actually run the jobs to say this job has to have a hierarchy of when it runs, right? It must always run under all circumstances. So if something exists and it doesn't have space to run, it'll go nix whatever's there and run the model, right? So the answer is yes, and also you can one-up it with preemption.
Okay, great. Thank you so much for your expertise. As I mentioned in the beginning, this session is recorded and it will be sent out post-event after processing. I hope everyone enjoyed the webinar today and have a better understanding of Nomad. And that wraps up things for us. Thank you. Have a great rest of your day.